Okay, so another inorganic compound. It's going to be salts. So when we're looking at salts, it is an ionic compound. So these are not shared electrons. These are just negative and positive that like to hang out with each other. So these are all going to be ionic compounds. And they're going to be specifically compounds that are containing anions other than a hydrogen ion. So a hydrogen ion has this little guy that he can donate, so he can actually give away that electron right there. So a salt is going to be something that's not a hydrogen, and it's going to have, cations other than hydrogen, and anions other than OH. So basically what this means is it is going to be not H2O. So when we're talking about a salt, it does not have hydrogen, nor is it going to have the OH. So it is going to be essentially something that is not H2O. So these are typically going to be called electrolytes because they can conduct electrical solution in the body. Some examples of these are going to be sodium, potassium, chloride. You can also have, I'm trying to think of magnesium. A lot of these are things that your body will actually eat. Oh, and iron, that's another good one. So things that you'll get from your food that are going to act as just the ions. So if you think about after a really heavy run, when the promotional items and the marketing that goes behind Gatorade and Powerade is being able to provide you with salts, you need something besides just the water. You already need the electrolytes in order to replenish your body. So that's what those are. Okay, this is really important for homeostasis, especially when it comes to maintaining their balance, which is the role of the kidneys. And if there is a disruption in any of this electrolyte imbalance, essentially all organ systems will cease to function. So as we get into later semesters and we talk about how things work, you will see chloride, potassium, calcium, all of these will show up again. And if they are not there, the system cannot work. Okay, we're going to do an overview of acids and bases. So if you've taken a chemistry class before, I hope this isn't new, but we're going to do an overview of acids and bases. These are both considered electrolytes, but they're going to be slightly different. So an acid will be something that releases the hydrogen ion. If it releases the hydrogen, this has a little positive sign. So it is going to be a proton donor. It's going to give. So in water, acids are going to release this hydrogen ion. So how much hydrogen ions there are is going to determine the acidity. So the concentration of the hydrogen ions, how much there is. So when you see concentration, it is done with these brackets that go all the way around. So that means quantity. How much of the hydrogen ion in the water will actually determine the acidity of something. So we're going to talk through some of the main liquids in the body and what their acidity ratio is. So concentration of the hydrogen ions is going to determine the actual acidity. That is different than a base. So a base is not going to release the hydrogen, it will accept the hydrogen. So that means that this is going to be a proton acceptor. And when this is happening, it is going to be the opposite concentration of hydrogen. So if you think about H2O, when this breaks up, you have one H and then you have OH minus because there's two hydrogen, and one oxygen. So this right here is the thing that can act as the acid or the proton donor. So whatever takes this will become an acid. Whatever takes this will become a base, because this is the proton acceptor. So as we're going through this, we'll talk about the levels of concentration and how these things work together, which is the pH. So this is going to be the concentration of acid and bases. It's very easy because they are just an inverse relationship of each other. So more hydrogen ions, more acidic. So it's going to be a floating scale. So the more hydrogen ions, the more acidic it is, whereas the more hydroxyl ions, so that's what these are, hydroxyl ions, the more basic it's going to be. So more acidic is related to hydrogen ions, basic is related to hydroxyl ions. And so this is a really, really, really important thing. So the more hydrogen ions in a solution, the more acidic that solution is. So remember that. So when we're talking about this, we're going to talk about something called a pH unit, and that will range from 0 to 14. So things that are going to be called acidic on that 0 to 14 scale have a high concentration of those hydrogen ions. So we're going to have a high pH. And then we're essentially going to have a low, sorry, not a high pH, low pH, high concentration of hydrogen, low concentration of hydrogen. So that's where we're starting. So if we have a high concentration of hydrogen ions, it will be a low pH. So that means on a 0 to 14 scale or a 1 to 14 scale, this is going to be a 1 if this is our scale. So if we have a high concentration of hydrogen ions, we're going to have a low pH. Same thing is going to be true for these guys. Basic solutions are going to have a low concentration of hydrogen. So that's going to be up here. Low concentrations of ion, and it will be a high pH. So this will be an acid, and this will be a base. So the scale goes from 1 to 14. So right in the middle between 1 and 14 is going to be 7.0. So what this is saying is that something that is basic is going to have a pH of 7.01 to 14. So anything that is basic is going to be on this side of the scale. It's going to be a basic. Whereas anything that is going to be not basic but considered acidic will be on this side of the scale. And it will be 1 to 14, or 1 to 17. And this will be an acid. So that's how the scale actually works. Acid is going to be 1 to 7.0, and this is going, or 1 to 6.99, right below it. 7 is considered neutral, and then this is going to be 7.01 to 14. That is how that process works. So you can see on this image right here, on the next slide, how that actually plays out. So when you're looking at this, remember that we said that 7.0 is acidic, is neutral. So that's going to be this right here. Neutral is 7.0. Right here is our blood, our main liquid in our body, besides that is made up primarily of water. So blood is actually going to be 7.4. So that means looking at this, that our actual body is going to be something that is going to be slightly basic, because 7.4 will live in this world right here, which is going to fall into our basic world. So our blood, our body, is going to be slightly basic. You can also call this as slightly alkaline. So if you've ever heard that term about alkaline water or the pH of your body, that is what it's referring to. But you can see some of the other things in our bodies and where or household items or other pieces and what those pHs are. So what we care about with a pH is something called neutralization and buffers. So we're not going to actually dive into any of these this semester. This is going to primarily come into play second semester with some of those physiology pieces and those systems. But with a neutralization reaction, if you actually mix these together, if you mix an base and an acid together, you are going to get water and something that is essentially neutral, a salt. So you can actually add an acid and a base and it cancels each other out. So that's a neutralization. And then a buffer, what a buffer will actually do is it will keep the pH. If we've got a scale of 1 to 14, a buffer will actually keep it from going from way down here to way up here. It will stop that process, and it does that by keeping things, by releasing and adding and breaking and removing hydrogen ions. So it just kind of rotates through that. Again, this will be covered in AMP2, but you just need to know the term buffer relates to acid and bases.